Okay, so this is part 3 of our graphing techniques here. We just got done in part 2 graphing y equals 2 cosine of 3x plus pi, and this is what it looked like. Okay, we had used these as our x coordinates and found y coordinate by taking 2 times what we usually have as our y coordinates, 1, 0, -1, 0, and 1. Multiply that all by 2. And you get 2, 0, -2, 0, 2. We were just talking about the amplitude, etc., how to find that when you have y equals something plus a sine or cosine of bx minus d. And I do want to reference, this is, usually I write it as bx minus d. I don't factor the b out. Okay, so that doesn't affect the amplitude, of course, which is the absolute value of the number in front of sine or cosine. The period, which is 2 pi divided by b, no matter where the b is. Okay, it does affect the phase shift, though, okay, which wasn't even on here. But the phase shift, if it's just written bx minus d without the b factored out, like up here, if it's just bx minus d like ours was, then the phase shift is d over b. In other words, the phase shift in trig is what is the horizontal shift. Okay, the horizontal shift. So let's look at this, okay? I'm going to show it on first of the equation, okay? Looking at this, we said the amplitude is the absolute value of A. A is the number in front of the cosine. So the amplitude is 2. Well, let's look at the graph. From the horizontal, the furthest away that the y coordinate is 2 from the horizontal. Okay, that was great. The phase shift is 2. Okay, and then we have the period. The period, if I was going to figure it out without, and I didn't have it graphed, the period is 2 pi over b. And b in this case is 3. 2 pi over 3 to get through one period. Well, one period goes from negative pi over 3 to positive pi over 3. That distance between, how far did it take me to get through one cycle? 2 pi over 3's, right? We can see it there. That's what the period is. Now, the phase shift is usually, where do I start? I usually start at 0, 1, right? I usually start at 0. That's where cosine starts. But this time, it was shifted to the left by pi over 3. That's where cosine, instead of starting at 0, it started at negative pi over 3. So the phase shift is, remember, horizontal shift. It's always the opposite of what we think, right? This says plus pi, but it was shifted to the left. It's shifted negative pi over b. Negative pi over 3 is the phase shift, okay? And that's what I meant by this. The phase shift, I said it's d over b. Well, that's if there's a minus here. Okay, there was a plus there, so it was negative d over b. Okay, if, however, they already factored the b out, sometimes you'll see it with it factored out, then the phase shift is just this number. Okay, let's take all that we learned and try to graph this now. Okay, all right, so key points. First of all, just looking at it, okay, I know that the amplitude is going to be 2. I know the period is going to be 2 pi over 4, okay, which is what, pi over 2. It's going to take pi over 2 to get through a period. It usually takes 2 pi, so this is going to be a tiny little quick graph, right? It's also, we didn't have a c before. This is my c. It's plus -1, okay? Back here, we said c plus, well, we have -1 plus this thing. It's written differently. The -1 is on this side instead of over here, -1 plus that, but wherever that is, it's going to be shifted down 1. Just like if we had y equals x plus 4 squared minus 1, right? It'd be shifted to the left 4 and down 1, right? It's the same idea here, okay? This is going to be shifted to the left pi over 4. That's my phase shift. Okay, it's not just pi. We have this 4 to deal with, and it's going to be shifted down 1, right? But let's, at least knowing that is helpful, right? I know the amplitude, I know the period, I know how we're shifted, okay? And some people just use that and they sketch it. I usually think, okay, the key points are usually, I just broke my pen, 0, negative pi over 2, pi, I'm sorry, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are usually my x coordinates. Well, that's what I wish I was taking the sine of. I wish I was taking the sine of 0. So how can I make 4x plus pi equal 0? How can I make 4x plus pi equal pi over 2? How can I make 4x plus pi equal pi? Okay, I want what I'm taking the sine of to be equal to these things. Okay? So each time what I'm doing is subtracting pi and dividing by 4, or subtracting pi and multiplying by a fourth, whichever way you want to think of it. If I subtract pi from 0, that's negative pi, and then I divide that by 4. So my first point is negative pi over 4. Here I'm taking a half pi minus 1 pi. If I take a half minus 1, that's negative pi over 2. And then, again, I can think of it as dividing by 4 or multiplying by a fourth. I get negative pi over 8. Here I'm going to subtract pi. That gives me 0. Subtract pi from 1.5 pi is pi over 2. Divided by 4 is pi over 8. And then here I'm subtracting pi from 2 pi. That's 1 pi. And pi divided by 4 is pi over 4. My y values with sine are usually start at 0, 1, 0, negative 1, 0. That's how sine goes, okay? But what I'm doing to my y coordinates is I'm multiplying by 2 and then subtracting 1. So that's what I need to do here. I'm going to multiply by 2 and subtract 1. Multiply by 2 and subtract 1. Multiply by 2 and subtract 1 to these what the y's used to be. Multiply by 2 and subtract 1. So 2 times 0 is 0, minus 1 is negative 1. 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0, minus 1 is negative 1. 2 times negative 1 is negative 2, minus 1 is negative 3. 2 times 0 is 0, minus 1 is negative 1. So here's what I'm going to plot. Okay, I'm going to plot those are my new x's and y's. So negative pi over 4, negative 1. Let me see here. Okay, negative pi over 4, negative 1. And then I go negative pi over 8, 1. Okay, not halfway there, sorry. 0, negative 1. Pi over 8, negative 3. And pi over 4, back to negative 1. So we go, okay. That's my sine graph. My amplitude I can see is 2, etc. Let's do this on Desmos. Might be just a tad more clear. I know that's hard to imagine. I'm so clear here with my writing. Okay, 2 times the sine of 4x plus pi minus 1. Let's look at it on Desmos, okay? 2 times the sine 4x, I think it was minus pi, minus 1. Let me look. I can't remember what it was. 4x plus pi minus 1. Okay, here we go. All right, here's pi over 2. They went the whole way down here to, this is pi over 2. So here's pi over 4. Here's negative pi. Okay, so we're at, did I do minus 1? Okay, there's my pi over 8, negative 3. My 0, negative 1. Up here was at negative pi over 8, 1, right? I'm not sure. Where that's coming from. Oh yeah, the negative 1. That's where I want to be. Here's where it starts. I can't get there. It's not showing me that. That's negative pi over 4. Okay, for whatever reason, it's showing me the x-intercepts instead. Here's where it started. Negative pi over 4, negative 1. Gosh, I wish I could land right on it, but I can't. Okay. There's negative pi over 4, negative 1. And then it went to pi over, negative pi over 8, positive 1. 0, negative 1. Negative, or pi over 8, negative 3. And then we're back at here at positive pi over 4, negative 1, which I just can't quite grab. Okay, I just can't get onto the negative 1 for some reason. Oh, I'm so close. Okay, so the amplitude would go, I don't know if you noticed, but y equals negative 1 is kind of the line that cuts it in half. So how far am I? I'm 2 away from the horizontal is the furthest I'll ever be, right? Down to, I don't say the amplitude is negative 3. I say the amplitude is, well, first of all, amplitude is always positive. It's 2. Okay, amplitude is 2. The period, what did that take? I went from negative pi over 4 to positive pi over 4. So that's 2 pi over 4s that took me to get through a whole cycle. 2 pi over 4 is pi over 2. And that's what we found for the, remember, the period is always 2 pi over b. So that was 2 pi over 4. I knew the period. I knew the amplitude. I know it's shifted down 1. Right? Usually I'm up here, usually my center line is at y equals 0, but I'm shifted down to y equals negative 1. Okay? That's what all that means. The phase shift is negative pi over 4. Negative pi over 4. It's d over b. Okay? Okay, so this is our sine graph. Picture sine when it usually is. Oh, here, let me graph it. If I just graph y equals sine x, okay, let's look at it. You see it? This is y equals sine x, the usual y equals sine. What we did, here's the starting point for sine usually, 0, 0. Well, it was shifted to here. It was shifted over here, and it's going faster, right? Instead of the period being 2 pi, my gracious, it only took, whoops, where's my start here? It only took pi over 2 to get through one cycle. You see what that did? And it also, of course, shifted it down. Usually my period or my amplitude is 1, right? And it's, see how spread out we are? It takes 2 pi to get through the whole period. And it's, but here my period is 2, or my amplitude, I'm sorry, is 2. And my period is only pi over 2. I'm getting through an entire cycle of sine in pi over 2. Okay, sometimes that helps to see that it all on the same axis. I hope so. Okay, so try that strategy, try the graphs, try the matching activities and the little quizzes that I have on quizzes, etc. Okay, and we'll talk about it in class, of course, as well.